So it was up here somewhere. Is that it? Yeah, okay, that's not that hard. I'm already there. That's why it accidentally worked. So yeah, it immediately went to something there. Let's see if I can get back there. So this, maybe I just have to use, yeah, so the sine of theta over, yeah, that type of stuff. It's not distracting at all or anything. Yeah. Yeah. Good change, yeah. Some of you are thinking, I might pay attention if you do that. Just kidding. No, you wouldn't. So, anyway. All right, there it goes. So here's the deal. We've just talked through how to make this stuff work. Excuse me. If we're trying to convert coordinates. If we have a rectangular coordinate trying to get to a polar coordinate. If we have a polar coordinate trying to go to a rectangular coordinate. But we've got to expand this to go a little bit bigger now. What happens if we need to convert entire equations? Could you do it one point at a time? Yes. Tedious though. Okay, so we can go full equation. Okay. Wow. Okay. All right, so guys, the good news about the now all of a sudden kind of the upgrade, maybe for lack of a better term, in terms of all right, what do I do or how do I pull this off if I want to go full on and switch around and convert these equations? The good news is, well, look at the conversion formulas. They're the same. Our conversion equations literally identical to the ones that we use for coordinates, or if we're using these for full equations. So anytime, again, polar to rectangular, remember x equals r cosine theta, y equals r sine theta. The step here, or steps I should say, is that we're going to substitute the conversion formula and we're going to solve for r. Under the rarest of circumstances would we solve for theta, but typically we're trying to get r isolated. If we're going the other way, polar to, we're trying to convert these polar equations, right? So if we are looking here rectangular and polar, we've got tangent of theta is equal to y over x, r squared is equal to x squared plus y squared, just like previously. Here we're going to substitute the conversion formulas again and simplify. Now, some of these, when we simplify, super easy. Others, it's going to just kind of be a little weird. Not the math that's weird, it's just knowing when to stop is kind of strange. We'll hopefully have time to talk through one of these here in a second. So, I think I'm going to probably spare you. Again, please don't write this down. But could we think of it this way? All right, yeah, I know that r squared, well, we know that r is equal to, or I'm saying x squared, we know that x is equal to r cosine theta. And I'm trying to say that this is plus y squared, and we know that y is equal to r sine theta. And we're trying to show how this is equal to 16. Could we work through this and probably use some trig identities and eventually make that work? The answer is yes. If we had more time, I'd show you the method as far as how we get there. But we can do a lot better than this. Think about your equation. Do we know off to the side that r squared is equal to x squared plus y squared? And if that's the case, as soon as I recognize x squared plus y squared, and we're thinking substitution now, what could I sub in place for x squared plus y squared? That's just r squared. If r squared is equal to 16, and we square root both sides, again, remembering our plus or minus, what are you going to tell me? R equals plus or minus 4. We got it. Okay? So, student earlier today said, oh, it's kind of like trig identities. Sort of, but we only have 4. Trig identities are a lot more, and plus, I don't know, I think these are maybe a little bit easier on the eyes. Okay? Now, this next one could be a little weird depending on how we look at it. Once again, could we sub in r sine theta for y, r cosine theta for x, and manipulate this and make it work? Short answer is yes. But I'm thinking about this a little bit differently. I see y and x, and I don't have an equation that specifically tells me what y is or specifically tells me what x is. But I do have an equation that tells me that tangent's equal to y over x. Do I have y over x right now? I don't. Could I make it into a y over x situation? Yeah, right here. How do I make that y be over x? Stupid as that sounds. Couldn't I just divide by x? There's a catch though. What has to happen on the other side? Also have to divide by x. Now, on the left side, I do have the y over x. What about the right side? X divided by x is 1. So here's where the conversion is going to happen. What did we say y over x is? Again, I'm using this guy over here. That's just the tangent of theta. Now we're saying the tangent of theta equals 1. I feel like we found ourselves here at one point. When I apply the tangent inverse on both sides, what is going to happen? All right, well, these are going to cancel. Theta is equal to, so where on the unit circle is tangent equal to positive 1? It's now positive. Well, little bit different than a couple slides back. Now we're talking about first quadrant, third quadrant. So what are we going to say? 5 or 4 and where? 5, 5, or 4. Those are the two spots where theta could be. All right, you see how we're doing that? How we're pulling that off? Attempting to pull that off? All right, guys, this last example, number 6, this is the one that has caused, I don't know, headaches for some people in the past. Not initially. Initially, usually people know exactly where to go. And that is that, all right, if I have r, I'm thinking that I want to use the fact that r squared is equal to x squared plus y squared. If that's what we're thinking, you are absolutely right. It's just a matter of how we get there that causes confusion. Where most people's minds immediately go, including my own, is that if I have r and I want to make that into r squared, easy. I'm just going to square both sides. Please don't write this down, by the way, because that's what we would do in order to get r squared on the left. The downside is that now my right side is going to become 4 cosine squared theta. Now on the left side, I have exactly what I want. I can, at any moment, I could sub in x squared plus y squared, couldn't I? But on the right side, am I any closer to getting rid of theta? That's really what this is about, is that if I'm in polar form, which is, I absolutely started there, I saw r's and thetas. That means that I want to get rid of all the r's and the thetas and get x's and y's. Does that make sense? So we have a definite means of changing this r squared to x squared plus y squared. I didn't get much closer to changing this back to just x's or y's. So instead of doing it this way, let's think this through. My goal was to turn r into r squared. And we just said squaring both sides was probably no good. But there's another way that I could turn this r into r squared. What would I do? Think about what r squared literally means. Could I just multiply by r? Would that work? And the catch is that if I multiply the right side by r, excuse me, the left side by r, I also have to multiply the right side by r. Now, the reason why this is going to work out much nicer this time is that if I'm just strategic with how I write this up, that gives me 2r cosine theta. Do we know what r cosine theta is? Off to the side, that was one of our originals. Didn't we say that x is equal to r cosine theta? Give me 1 second here, guys. So in place of r squared, that's going to be x squared plus y squared is equal to 2x. All that we do to finish this is I subtract it over. X squared plus y squared minus 2x equals 0. And that might not look like much, but is that a conic section? It's a circle, isn't it? It's not in standard form. We don't need to get into standard form, but that is a conic. That's the only reason why polar stuff and conics live in the same chapter. Okay, is that we got into, most people look at this and we think, all right, well, I'm going to have to keep going. No, we're done. We got that into a general form. All right? So guys, make sure that if you did not already notice the adjustment on the homework assignment, that we get that written down. I'm going to stop the video here. Just realize that's